Hey there, welcome back to the channel. Today we are going to solve another LeetCode problem, that is maximum subarray. So let's see what our problem is saying. So we are given an integer array nums and we need to find the subarray with the largest sum and we need to return its sum. So let's see this problem with an example. So in this array of integer we need to find the subarray with the largest sum. The subarray must be contiguous. So in this array, this is the subarray 4, -1, 2 and 1 contains the largest sum as 6. That is 4 plus -1 plus 2 plus 1 equals to 6. So we have to find out the largest sum of this subarray. Now let's see how can we solve this problem. So let's see, we are given this array of integers. So now let's talk about the naive solution. So in this naive solution, we are going to use two nested for loops. Two nested for loops approach will take time complexity of O of n square. So using this two nested for loops, we can generate all possible contiguous subarray, and we will find out the sum of all possible contiguous subarray sum and will pick the maximum. This approach will take O of n square time complexity, and this is not the efficient solution for this problem. We have to do something better. We can solve this problem in O of n time complexity using two variables. Let's see how can we do that. So before moving forward, let's discuss what is subarray. So it could be one element, it could be two element, it could be three, and each single element can be a subarray. So this alone can be a subarray. So what could be the possible subarray in this case? So let's try what are all the possible subarrays in case of this array. So let me reduce this array in this case. Let's say we have -2, -1, -3, 4 and -1. Let's say we have this array and we need to get all the subarrays of this array. So what are all the possible ways? That is -2, 1, -3, 4, -1. Then will we have for -2, what are the possible subarrays for -2? These are -2, -1, -2, -1, -3, -2, -1, -3, -4, -2, -1, -3, -1, 4, -1. So these are the possible subarrays for first element, that is 2. Similarly, let me write for all the elements. These are for 1 we have 1, -3, 1, -3, 4, 1, -3, 4, -1. These are for 1. Similarly, let's write for 4. These are 4, 4, -1. Similarly, for -1 we have -1. So these are all the possible subarrays for this particular array, right? And now we have to find the subarray with the largest sum. And in this particular array, this is the only array which is having the largest sum, that is 4. The problem is how we are going to find out that. One approach is that we can find using the two for loops and get all the subarrays, but that is not a good approach. That is taking time complexities of O of n square. So let's see how can we optimize this approach. So for that I'm going to use one variable, that is sum, and another variable that will be maximum sum, in which we are going to store the maximum sum and we are going to return that. So let's first initialize the sum as 0. Let me write the array again. And maximum sum we can take as the first element, that is initially -2, or the first subarray which is having the largest sum. So this is -2, and we will be keep updating the maximum sum whenever we found the maximum sum which is greater than -2. So firstly, in the first iteration sum is 0. So when we traverse from the first element, so it will become 0 minus 2, that is equals to minus 2. So minus 2 is greater than minus 2, that is no. So we don't have to update this. But one more important thing is, that is, if sum is less than 0, then we are going to update the sum as 0, because we don't want to consider the negative numbers, because negative numbers obviously are not going to be the larger. So we are going to update this as 0. So again the sum is 0 when I equals to 0. Then we'll move to the next element, I equals to 1. Again sum is 0. Now it will be 0 plus 1, which is equals to 1. So sum is 1, 1 is greater than minus 2. So we are going to update the maximum sum from minus 2 to 1. So till now our maximum sum is 1. So in the next iteration we'll save 1 minus 3, that will become minus 2. So 1 is already greater than minus 2. So we are going to update this maximum sum. But we are going to update the sum to the 0, because sum is less than 0. Moving to the next element, that will be 0 plus 4, that will be equals to 4. Now 4 is greater than 1, so now our maximum sum is 4. And then move to the next element, that will be 4 minus 1, that is 3. 4 is already greater than 3, so we are not going to update the maximum sum. So we have found the maximum sum equals to 4, and we have reached till last element. So at the end we can return 4. So this is the easiest approach in which we can solve this problem. So in this, the time complexity is O of n and the space complexity is O of 1, because we have used only two elements, that is sum and maxsum. So let's see how can we implement this solution. Now let's implement our algorithm. So int current equals to nums of 0. It means that the maximum subarray sum including our current element. Int max equals to nums of 0. It means that the maximum subarray sum of our current subarray or our current array. Now let's iterate for index 1. Int I equals to 1, I is less than nums dot length and I plus plus. Right inside this, let's compute current equals to math dot max nums of I and nums of I plus subarray sum on the left or our ith element, including the immediate left element, that is current. After computing current, let's compute the max. Max equals to math dot max and max comma current element. This is our core algorithm, and at the end we are going to return the answer as max. Once we are done with this loop, the answer will get in the max variable. And this algorithm is going to take the time complexity of big O of n and space complexity of 1, because we are iterating our array or we are scanning our array only once, so that is why it is taking linear time complexity, and we are using two variable, it is taking constant space complexity. So now let's run this code, and we have all the test cases accepted. Now let me submit this code as well. So yes, it is accepted. So I hope you found this video helpful. In case you have any doubt, you can ask me in the comment section. And if you like this video, please subscribe to my channel. Thank you. I'll see you in the next one.